Hello everybody, I hope you're well. This video is going to be a follow-up video from my previous LinkedIn post where I talked about how to gather system information from different networking devices such as Cisco, Juniper, FortiGates, F5s, yeah. And in addition to these devices, I've also added a few more devices for you. So in today's call, we're also going to talk about the NXOS devices and the Cisco wireless LAN controllers, which use the Air EOS module. So without wasting any further time, let's get started. Right. So this is my Ansible playbook. So like I said, we are using Ansible playbook to connect to all these devices. All these devices, if you go to the Ansible web page, you will see a list of modules that they have developed for different vendors. So it is called collections, I guess. So if you go to Ansible web page and if you go to the collection section, I will send the link in the description. You will see a collection of all the vendors out there like Cisco, NXOS, or FortiGates, F5s. All the devices, mostly all of them, I was able to connect using the readily available modules. However, for Cisco wireless LAN controllers, which use the Air EOS module, I had to go and take a detour and create my own Python script using NetMiko and text FSM parsers, and then use Jinja templating to render all the variables. I will be covering that in detail, and that was the only exception. But other vendors, I was able to use all the modules readily available in the collection section and define it in my playbook. So this is the first task in my playbook. We don't like duplications. So the first step is removing the old inventory file that we've created and creating a new file which reflects the present state of the network. Then we move on to the section called Cisco IOS XE devices. You define all the variables to connect with the device, like you define the username, you define the password, the operating system type, and the Ansible command timeout, so that it doesn't time out before the router has sent all the information back to Ansible. It's a very useful command. You can reduce a value in your case. I think I was just testing with it. So you can set the right timer for your network and take it from there. So after you've defined all the variables, the next task is what command you're going to run on your device. So because I'm collecting all the system information like the hardware information and the software information, I think show version command was enough for me, and I was able to collect all the information using that command. Next, I register the output in a variable called show underscore version underscore output, and I print that out. Normally, I like to print the output on my in my playbook so that I can see it on the screen, so that you are confident that you are seeing what what you are really after. It lets you pinpoint the exact information that you want to extract from the raw CLI output. It's a great debugging tool as well. And it gives you confidence that yes, you're on the right track. It is able to see the right variables, the right structure, and it is able to get the information correctly. I like printing the output on the screen as I go along. And I also like to run my Ansible playbooks in verbose mode, which is good. So it takes you behind the scenes and you can see what's exactly happening in your playbook. So after I've printed all the output on the screen, I'm using the Genie parser library for iOS operating system, and I'm asking them to parse the output for show version, and I'm saving the output in a variable called underscore show underscore version. So step number one, I've got the raw CLI output. I've parsed it using the readily available Genie parser library. And then third step is I'm rendering all these variables using Jinja templating. Jinja templates. I will be sharing the structure of the Jinja templates that I've used shortly. And in this case, the abbreviation SRC stands for the source where I've defined my Jinja template, which goes by the name of Cisco test.j2. Then the destination is the path where you would like to save the information that you've just collected. And if you can see the inventory underscore host name variable, which is in double curly braces, that becomes the unique identifier for all the devices. So in our network, or in any network for that matter, the network device will always be unique. And we are leveraging that fact to save all the files because the location will be same. If you see, everything else in the path is same except for the name of the device, and that will be the unique identifier, and all the files can be identified based on the host name, which is unique to every device on the network. Moving on, Cisco XR devices. So I'm using the Clay 584 parse underscore Genie library to parse the data. We define the variables here to connect to the device. Just a quick note now, how do we authenticate to the device? You can either use RSA private and public keys to authenticate to the device. And I did my initial testing using the private public keys. But in the end, what I did, I created a static TACACS account. And I created a user with read-only access and defined that user on TACACS. And using that static TACACS user account, I'm communicating with all my devices. So there are many approaches. That's the approach I took in this particular instance. So you save the output of show version in a variable called show underscore version underscore output. You print the output same format and you pass it through a Genie filter. Just make sure, in this particular line, passed underscore show underscore version, make sure you define the correct operating systems. So it will be iOS XR in this case. So moving on, we've got the pass data. We just pass it through the Jinja templating. So in this case, I had to run two sets of commands. That's why I'm repeating the steps, because I wasn't able to get all the output in just one command. So I had to run two commands, parse that data, and once I got all the information that I needed, then I'm using Cisco the Jinja templating to render the variables in a file. So that's Cisco iOS XE and XR devices done. NX OS device we are going to talk about at the end. Let's discuss about Juniper devices. Now, Juniper devices use netconf over SSH port, which is port number 830. TCP port 830, which needs to be allowed on the network. If you can allow it on the network, good. If not, there is a workaround that we can do, which I've done in this case. You can which is you can force the traffic to go over port number 22. So as you can see, I've defined all the variables, and there's this variable called netconf underscore port, which is 22. And also we need to make a setting in the inventory file. I think I will share the inventory file now while we are at this topic. So this group called Juniper underscore devices maps to all the hosts which are Juniper. As you can see, when you mention the IP address, if you put :22, it will force all the traffic over port 22 if you are not able to allow port 830, TCP port 830 on your network. This is a workaround, as you know. And then everything else is the same. You define Ansible underscore connection, which is netconf, and Ansible underscore network underscore OS, which is the operating system, which is JUOS. This is the only, this configuration is, which is different from the other configurations, so I thought I'll mention it. Everything else is pretty much the same. So once we have connected to the device, we are using Juniper networks.junos underscore facts module to get all the facts back from the device. And these are the commands that I'm running to gather all the system information, as you can see. So once we've got everything, the beauty of Juniper devices is the data is already passed. Right. In Cisco devices, once we got the raw CLI output, we had to parse it using the Genie parser library. But in Juniper, you already get structured data back from the device. So, you don't have to do step number 2, which is parsing the raw CLI output, because you get parse data, which is a big bonus. So all you've got to do now is pass that parse data through the Jinja templating and render the variables. Next vendor on our list is the F5 load balancers. I'm using a module called F5 networks.f5 underscore modules. We need to allow TCP port 443 and HTTPS port 8443 to allow end-to-end connectivity. Please bear that in mind, because initially I was getting loads of errors, and it turned out we had connectivity issues because these ports were blocked. So you define the variables to connect to the device. And then I'm using the big IP underscore device underscore info module to gather all the system information. So there is a subsection called provider. And please bear in mind, the server field is the IP address of the device that you want to communicate with. And like I said, it uses port 443, so make sure it is allowed. And if you want to check, so how do we check if you want to communicate to a device on a particular port, be it 443, be it 8443, any port? What I do is I just telnet to the device, and I just put that port number after a space. If it works, that means that port is allowed. Otherwise, there is a problem. So telnet space IP address space the port number over which you would like to connect to the device. Okay, so you register with the result, and debug is for printing. So you print the result. Like I said, it's always good to see, what's happening behind the background. So I like print statements. And then I'm just slicing and dicing the information. So in my Jinja templates, whatever keys I am calling, I'm calling through Ansible, like serial number, hardware, MAC address, host name, or version number. I'm just defining them here so that they are readily available. as you can see. Display complete big IP information. So in my output, it's a nested output. So there is a dictionary called result. Within a dictionary, there is another dictionary called Ansible underscore facts. Within that dictionary, there is another nested dictionary called Ansible underscore net underscore system. So this could be tricky in the beginning, I have to say. It comes with a lot of practice, because sometimes the nested object could be a list. So you have to approach it slightly differently. But if it's a dictionary, we can just use dots to navigate to the correct path, and then we can pull the information. So something to bear in mind. But in our case, it was just a series of nested dictionaries. So using result.ansible underscore facts .ansible underscore net underscore system underscore info dot product underscore version, I was able to pull out the version information of that particular device. So navigating through the past data is a skill as well, and it comes with practice. It's really interesting when you do it, and sometimes you have to do a lot of print statements to actually analyze what your output is, and then keep trying different techniques to get to your desired output. Next step is to write the output variable to a file called result1, and because I ran two sets of commands here, I'm saving them in a different variables called result1, result2, and just so my program doesn't get confused and it is able to locate all the files. And the last step is the same. I'm rendering these variables using Jinja templating. The next device on our list is a FortiGate device. It will also use port 443 for connection. We need to allow that. And it uses connection HTTP API for connection. And I'm using a collection here to connect to these FortiGates. It's called Fortinet.FortiOS. You define all the variables that you need to connect to the device. And then we define the task using Fortios underscore configuration underscore facts. Now, one thing to bear in mind about these FortiOS devices is the access token. We can either use the CLI or we can use a graphical user interface, but we need this one-time access token that we need to define in our playbook to authenticate to the device. And once we have authenticated, we can get the information, and the information that we get back is thankfully passed again. So we can just move on to displaying that information in a nice format using Jinja templates. Now, the next device on our list is the Cisco wireless LAN controllers. Oh my God, it was a challenge to connect to these devices. And I had to try lots of different things. I will be covering these devices in a different session because what I used was NetWeco, TextFSM, Jinja templates, and then I'm returning the output back to Ansible. So it's all in one place. The information comes back in one place. But I will be covering this in a different session. Let's move on to the NX-OS device. So the NX-OS devices, basically, we need to define these variables to connect to it. And I'm using we can use, I've heard that Cisco NX-OS devices, if we connect them using an API interface, the information that we get is already structured. We can do that. But in this case, I'm just using the network CLI option to connect to them. and I'm parsing the data using the clay584.parse_gd parser. So that's it, guys. And okay, sorry, there is some more script left. So yeah, I'm passing the output back using the genie parser. And as you can see, I need to define the operating system as NXOS. And we just print the parsed output. And again, in this case, I had to run two sets of commands, show version and show inventory, because I think one field, I wasn't able to collect all the information in one command, so I had to run two commands. And once I've collected all the data, I'm rendering the variables using the Jinja templating. And the final bit of our playbook is assembling. Using the assemble module, Ansible module, I'm collecting all these files that I created, which are distinguished by their host name. I'm assembling all these files and just consolidating them in one in one file, just to keep it clean and nice. And basically, in addition to that, what I've not shared with you is I'm also running a cron job, which will run like every once a week, 6 o'clock in the morning. It will run this playbook. It will collect all the information. It will assemble all these files. It will assemble all the data in one particular file, and it will email all the project stakeholders what the current state of the network is. If you want me to share that with you, let me know. I can also do another session on how to use cron jobs and call the Ansible playbooks to run your scripts on the network. So very quickly, guys, let's talk about the inventory. The inventory file is, so basically these are the names that maps to the hosts on the Ansible playbooks that we defined. And everything else is same. Device name followed by the IP address. Device names. If you've got hyphens in your device names, that won't work, because hyphen is interpreted, beg your pardon, as minus sign. So instead of hyphen, we have to use underscore. So that's what I wanted to share with you. And the only exception in this inventory file is the Juniper, is a group called Juniper_devices, because it uses netconf over SSH port 830. And if it's blocked on your network, we have to use the alternative, which is to force the traffic over 22. So you have to use :22. So, and Ansible_host basically maps your IP address to a name. So when your playbook runs, you can see your device name instead of the IP address. So it's a good technique because it's impossible to remember all the IP addresses in the network. So it's good to see your device names, but they need to be registered on the DNS, obviously. So that's it from me, guys. I hope you found this session useful. If you have any questions, you can find me on Twitter, LinkedIn, YouTube. If there's any network topic that you want to go through in detail, let me know. I'll try my best to cover that. And thank you very much. I hope you have a good day. Thank you.